start now. So if you have any question about this course, basically it's part of our cryptocurrency course. So if you have any question, you can ask right now. So if there is no question, so I'm going to start. I hope you people are all doing well. We are going to talk about smart contracts, and we will refer to Java programming language because the smart contract are similar to Java classes. Smart contracts, but there are some differences, and the main difference is that smart contracts have monetary cores. This means that they are used for transferring a cryptocurrency from one account to another account. So the main purpose or the main application of a smart contract is to transform the paper contracts into digital ones. So one example of the paper contract is the renter agreement. So renter agreement, what we do in case of renter agreement, that the renter transfers, renter accesses application, and that application receives the renter's rent, and then it transfers money into the this owner's account. So there is some manual effort involved in this application. So we can get rid of that manual effort with the help of a smart contract. When we launch a smart contract, it will automatically detect rent from the renter's account, and then it will automatically transfer it into the owner's account. So this is the application of a smart contract, and that's why we are using it, because it is transforming the manual, the paper agreements into digital ones. So now we will see one example of a smart contract, and this is this is called test. Its name is test, and it is similar to Java class. Instead of a class, we have got contract over here. What we are seeing in the Java, we have got instance variable, and instead of the instance variable, we have got state variables here, and and the name is owner. And in addition to this, we have got a constructor. Constructor is used for initialization. And in case of Solidity also, we are doing the initialization, but here we are assigning an address to the owner, and then we can access this address in different parts of the program if we are performing a sensitive executing a sensitive statement. Smart contracts can be accessed by anybody, but we have to protect our sensitive statements. That is the statements of the smart contract, and we do it with the help of guard statements. And one simple guard is that we will use the owner's address as a guard, and we will check if the caller of the smart contract has the owner's address. If it has the same address as the owner, then we can say that it can execute the sensitive statements of the smart contracts. So this, and we have got a kill function, and kill is used to destroy the smart contract. So this is why we need why we need to destroy the smart contract at the first place. We do not do this thing in traditional programs, but why are we doing it in a smart contracts? Because smart contracts deal with cryptocurrencies, and they can have vulnerabilities, and attackers can get advantage of this their vulnerabilities. We have got the self-destruct statement, and self-destruct statement is used to destroy the smart contract if it's vulnerable. If a smart contract is vulnerable, then owner will destroy the smart contract and then relaunch it on the blockchain. So that's why we have got self-destruct statement in the smart contract. And the other statement is the function. There is no name to assign to the function, and this function is called fallback function, and it has got some very important code that is it is used to receive ether, and we can also use it for transferring ether. And for this purpose, we have got payable keyword. If the function is associated with the payable keyword, then it means that it can receive the fund it can receive the ether and it can also transfer ether. So we can use this instead of